Well, everybody, welcome to our Everything ALS Expert Talk. You know, the hour and a half that we spend together today, it's very valuable, but we know that your challenges are 24 hours a day, 7 days a week. We want to make sure that you always have support when you need it, like at 3 o'clock in the morning. Our free Everything ALS app has you covered. You can download it from the App Store or the Google Play. And inside, you'll find our AI guide, always ready with answers drawn from our past expert talks, available 24/7. And that's everything that we have talked about for all of our past years. And even more importantly, the app connects you with the Pathfinders, people who are on this journey just like you. In the Connect tab, you can read their bios, see their pictures, and reach out directly to any one of us. And we would be extremely grateful to get back to you as soon as possible. And with that, I'll turn it over to you, Christian.
Thanks, McFinn. Hi, everybody. Christian Rubio here, Executive Director at Everything ALS, and it's my pleasure to introduce our program this week on our Expert Talk series titled Genetics and ALS, What New Discoveries Mean for You and Your Family. And it's presented by Jennifer Roggenbuck. And Jennifer comes to us from The Ohio State University, where she's a genetic counselor and professor. And she's studying genetic testing and counseling outcomes and best practices in ALS clinical genetics. A little bit of housekeeping before we get going. Please always remember that these programs are done live so that you can actually ask your questions of the experts. So by all means, ask your questions in the chat. At the end of the presentation, we'll do Q&A with our speaker, and we will make sure that the program and its recording will be live just within a few days of the live session on YouTube, so that you can share it with your friends and family as well. So with that, I'm going to turn it over to our featured expert speaker tonight, Jennifer. The floor is yours.
Thank you so much for that introduction, and thank you for asking me to join this webinar and discuss the genetics of ALS, which is my favorite topic. And I hope to cover some of the updates that have occurred in ALS genetics over the past 10 years and kind of give you a perspective on how far we've come and some of the questions that we're still grappling with. So these are my disclosures. Today, I hope to spend just a few minutes reviewing ALS genetics just to kind of set the table and be sure that we're all on the same page. Then I'll discuss the current recommendations for genetic counseling and testing in ALS. And that's an effort that I was involved with for several years. So I'm happy to share our product with you in terms of our recommendations. Finally, we'll spend a little bit of time talking about ongoing challenges and questions that that the genetic testing can lead to. So we can answer some questions, but we don't have all the answers, and that's important to remember on this journey. So when I first meet a family in ALS clinic, often one of the first questions I get is, does ALS run in the family? Is it genetic? And in a minority of cases, there is a family history of ALS, and we call that familial ALS. However, the majority of cases, we don't see any family history, and we used to refer to this as sporadic ALS, but that's a confusing and misleading term. So these days we tend to say isolated ALS or singleton ALS, but it simply refers to the fact that we're only seeing one person in the family with ALS, and that is the typical scenario. There are some differences between familial ALS and cases of ALS with no family history. Familial ALS typically runs in the family as a dominant trait, meaning that if you have it yourself, that predisposition can be passed on with a 50-50 chance to each child. Typically, people with familial ALS have an earlier age of onset. So that is one of the things we look for, kind of a soft sign with respect to age of onset that does increase the risk for a hereditary component. Another thing that we can see in familial ALS is the combination of ALS and frontotemporal dementia running in the same family. And frontotemporal dementia is a special kind of dementia that's distinct from Alzheimer's dementia, and FTD is more characterized by changes in behavior and personality, more so than memory. But many people are not aware that some forms of genetic ALS can present either as ALS or FTD. We now have more than 30 different genes that can cause familial or hereditary ALS. However, the penetrance of those genes, meaning the likelihood that someone with one of those genetic changes would actually develop ALS, varies. And this is a really important concept that I'm going to return to at the end of the talk, because we do have some new data about penetrance that's really important for families to hear about. So with genetic testing, we're able to identify a genetic cause in up to 75% of familial cases. With respect to isolated ALS or singleton ALS, in these cases, we usually don't know the cause, and the onset typically is later than in familial cases. And even though there's no family history, we still do find a genetic cause or a genetic variant that's underlying that condition in about 10% of cases. So this is a really important thing to remember, is that even if you don't have a family history of ALS, there's still about a 10% chance that you could have a genetic form of ALS based on our data. So if you're thinking about your own family history, which category do you fit in? Do you have familial or singleton ALS? If you have a close blood relative with ALS, that's what we classify as familial ALS. However, if you have pretty good knowledge of your family history and you don't know of anyone else who has ALS or FTD, that would be considered singleton or isolated ALS. And as I mentioned, a family history of close relatives with dementia, specifically FTD dementia, is a risk factor for hereditary ALS as well. And if you're thinking about having genetic testing or discussing this with your neurologist or your genetic counselor, it's important to kind of gather information about your family history so you can report that back. Is there anyone else in the family who's had ALS, any kind of dementia, psychiatric disease, any other kind of adult neurodegenerative condition can impact the risk assessment and the likelihood that a genetic form of ALS might be at play. So as I mentioned, there are many, many different genes that can cause or predispose to ALS. However, there's in our population here in the United States, there's 4 that are kind of like the big players. That includes C9orf72. This is the gene with the weird name. It's simply named for the location on chromosome 9 where that gene sits. We all call this gene C9 for short. And this gene can cause ALS, FTD, and possibly psychiatric illness as well. It's dominantly inherited. The next most common gene is SOD1, and this gene causes motor neuron disease only. In other words, does not pose a risk for dementia. At least that is that's widely accepted. Then we have FUS and TIR-DBP. Those are not as common, and one of the things I wanted to highlight here is that all of these genes can manifest either as or with frontotemporal dementia, except SOD1. So SOD1 is distinct in that way. The other thing I want to point out is that for each of these genes, if you have a genetic variant in one of these genes, that doesn't mean for sure that you will get the condition. And again, I'll spend more time on this later. There are some exceptions to that depending on the specific variant, but in general, we see variable penetrance in families, meaning some persons in the family who have that genetic change will get disease, but others won't. So just to say a little bit more about that C9 gene, this is the gene that's on chromosome 9 that was only discovered in 2011. So believe it or not, this was like the most recent like big discovery as far as an ALS gene. And it is the most common genetic cause of ALS and FTD in persons of European descent. So of course that includes, most of our population here in the United States. This gene is transmitted as a dominant trait, so with a 50-50 risk of being passed on with each child. However, that penetrance is incomplete, meaning that not all children who inherit that variant will develop disease. So it's important to remember that this is one of those genes that can cause ALS, FTD, a combination of ALS and FTD, or no symptoms at all. And this gene has a unique variant, which predisposes to ALS, and that is it's a repeat expansion. And a repeat expansion is part of the genetic code that's normally repeated a few times, say 5 times or 10 times. But if that repeat grows larger, in this case above 30, some labs use a cutoff of 60 repeats. That is what triggers the predisposition to ALS and FTD. And this is a unique genetic mechanism that is common to some other neurologic disorders. And it's a unique pathomechanism that's particularly challenging to sort out and difficult to devise a therapy for. So that's something that has impacted the clinical trial pipeline for this particular gene. So just to say a little bit about the history of the C9 expansion, it's pretty interesting. And genetic evidence suggests that this expansion has a relatively recent history. It arose in Scandinavia approximately 1,500 years ago. So in the terms of human evolution, this is just like a millisecond ago. So this is really interesting. And the current distribution of the C9 expansion seems to reflect the geographic range of the Viking expeditions. And the expansion is most common in Scandinavia and in other frequent Viking destinations, such as Ireland and Sardinia, coastal areas and waterways. And this is believed to reflect that, the expansion arose in Scandinavia and then was spread with the Viking conquests. ALS is a condition that occurs worldwide. However, there are differences in the incidence of ALS, and ALS is more common in people of European descent. The frequency of different ALS genes varies in different populations. And as I mentioned, the C9 gene is the most common one in people of European descent, but in Asia, SOD1 is the most common. And many parts of the world actually haven't been studied. So what this means is that a lot of the knowledge that we have is really drawn from the study of European individuals. And we have really poor data on, say, empiric recurrence risks for family members with ALS outside the European population. So unfortunately, if you don't happen to have European ancestry, our data is not as good in terms of estimating risks for having a genetic cause and the likelihood that a family member would also be affected. So we're trying to diversify our research cohorts and address this issue, but it's going to take a while to catch up. So why do we talk about genetic testing in ALS and genetic counseling? And what is genetic counseling? So genetic testing and counseling can help families understand why ALS occurred. In some cases, we can clarify disease risks to relatives, and in some cases, allow healthy relatives to have genetic testing to find out if they've inherited a genetic predisposition to ALS or FTD. Also, when we do find a genetic cause, that enables families to undergo pre-implantation genetic testing. So they can do a special IVF procedure whereby they do not conceive embryos that have the genetic change. This is only possible with that genetic diagnosis. Also, some people are motivated to participate in genetic testing and counseling to join natural history studies or gene-targeted clinical trials. And of course, now we do have one gene-targeted therapy for SOD1-related ALS, and since the approval of Qalsody in 2023, that has been a big motivator for people to seek genetic testing because that treatment is only for people with ALS who have a SOD1 variant as the underlying cause. That being said, I still like to remind people of, the pros and cons of genetic testing. And when I'm discussing the possibility of testing with a person with ALS and their family, we kind of, hit on these various points because what's important for some people might be, not important for others and so on. So on the pro side, as I mentioned, genetic testing can identify a cause. In some cases, it can enable us to be more specific about prognosis and whether or not FTD is a risk, for example. Having a genetic diagnosis can open the doors to research participation and clinical trials. And some people are interested to clarify risks to family members. Do my family members have a significant risk of getting ALS as well? And of course, if you happen to have a genetic change where we do have an approved treatment, then that genetic change or that genetic diagnosis is the door or gateway for that treatment. Now, on the con side, reasons against testing include we don't always find a cause, and in fact, if you don't have a family history, most of the time we don't find a genetic cause. We might not be able to give any more specifics about disease progression, even if we have a genetic diagnosis, and treatment may not ultimately be changed. And in some cases, genetic testing might be expensive. However, currently we do have multiple free testing programs that are available for people who are affected with ALS or at risk, such that there's no charge at all for the testing. Now, finally, and this is a big one for some persons with ALS, there's a concern about burdening family members. And some people think or experience that, having a diagnosis of ALS is a significant life event on its own. And then to add the possibility of learning that it might be a genetic ALS and then having to face, spreading that word through the family is something that is challenging to consider for some people. So that's a reason maybe to hold off or decide against genetic testing. So a lot of times people are curious to know, well, what's the chance that I would have a genetic finding or a positive result on testing? And that really depends on your family history, as I mentioned. So for persons with familial ALS, the chance that we would find a genetic cause is as high as 75%. And that kind of depends on the strength of the family history. So if you have a really strong family history with multiple relatives affected, we usually find it about 75% of the time. If you don't have a family history, then the likelihood that we would find a genetic cause is about 10%. So it's still a minority of cases, but it's not zero. And as I mentioned, positive genetic results have significant implications for family members, and that's where genetic counselors come in reviewing what those implications are and helping family members determine what actions to take, which could include things from just being educated to seeking testing or predictive testing to seeking reproductive interventions. So I'm happy to say that we are now in an era of gene-targeted therapy for ALS, and this graph depicts the history of gene discovery in ALS going back to 1990s when SOD1 was the very first gene identified in familial ALS. And today we have an FDA-approved treatment for SOD1, which is an antisense oligonucleotide, as I mentioned, was approved in 2023. So if you have a pathogenic variant in SOD1 that is responsible for your ALS, you can get this treatment that is targeted for that specific genetic change. ATLAS is a clinical trial of Qalsody in healthy individuals who have a SOD1 genetic change. So typically these are family members of persons with SOD1 related ALS, and they enroll in this trial to be followed clinically. Their biomarkers will be checked, and if they show evidence of impending motor neuron disease, then Qalsody is started before any overt clinical symptoms. So this is really exciting, and if this trial is successful, it would open the door to pre-symptomatic treatment for ALS, which is super exciting, and that's not something that I ever thought I would see in my lifetime. Finally, Fusion is another clinical trial that is testing an antisense oligonucleotide to the FUS gene in individuals with FUS-related ALS. And both Fusion and ATLAS are wrapping up now, so I'm really looking forward to seeing results of these studies in the coming months. As you can see, there's many genes that we currently do not have a clinical trial or a therapy, and that includes C9, where there's been a number of setbacks in our quest to get a clinical trial off the ground in the United States. So with that, I'm going to shift gears a little bit and talk about my efforts, which was a team effort to standardize the practice of genetic testing and counseling for persons affected with ALS. And despite all of these great discoveries that I showed you on the last slide with all of these genes that we've identified in families with ALS, not all persons with ALS as of 5 or 10 years ago were being offered genetic testing. And also there was no consensus as to what that testing should consist of. And in addition to those inconsistent practices, there were issues with some of the laboratory tests, particularly related to that C9 gene that I told you about with that repeat expansion that can be difficult to detect. And there were problems with laboratories giving inconsistent results with that repeat expansion. So I and my colleagues, Dr. Matt Harms and Dr. Steve Kolb, who I think you're going to hear from later in this venue, we submitted a grant to the ALS Association to try and undertake a project to review the evidence and provide guidance for what genetic testing should be offered to persons with ALS. And our hope was to standardize testing practices among neurologists, genetic counselors, or any person caring for persons with ALS, and then also to accelerate the rate of genetic diagnosis in the ALS population so that we can better understand what therapies are a highest priority and also set up the population to participate in gene-targeted therapeutic trials. And we went through a whole long, really boring process that I'm going to kind of gloss over here, but it was a lot of work of reviewing the literature and kind of defining what our clinical problems are in this space. And all of that work culminated in an expert panel that we voted on each of our recommendations and revised them until we reached 80% consensus for each recommendation. And you might recognize some of the names in the field here on the screen. We've got Dr. Bedlack and Dr. Benatar, as well as my colleagues, my genetic counselor colleagues, Lainey Dratch, Ellie Harrington, Carly Siskin. So this was the culmination of many years of work, but it was the fun part. And our guidelines now address testing, so what testing should be offered, what laboratory techniques should we use, and also what information should be provided to persons with ALS before and after testing. And that is what genetic counseling really is an education and risk assessment that's individualized to the person. So I'm going to really speed through these because you can look at the paper if you're interested, but basically our guidelines boil down to all persons with ALS should be offered comprehensive genetic testing. And that includes the big genes you see here, as well as any gene that the FDA approves a therapy for. What we don't want happening is laboratories offering testing for a gene that does not have definitive evidence as a cause for ALS. And that actually happens because labs get in this race to have the biggest test, but that's not always best for the patient because we don't want them getting results on a gene that makes no sense. So we have a lot of very technical recommendations with respect to how C9 testing should be done. Again, I'm going to skip over this. We want testing to be comprehensive rather than let's do one gene, then the next, then the next. Let's do all the genes at once to get the result back to the patient and family as quickly as possible. Now, we also cover genetic counseling recommendations, and it's really important that the neurologist or the genetic counselor review the family history information so that when we get results, we can really explain what it means for every person in the family. It's important to explain about inheritance. Is the gene a dominant gene or a recessive gene? What is known about the penetrance or the disease risk that is associated with variants in that gene? And it's also really important to give personalized risk assessments. And this is where research has shown that we fall flat. We give information to the person that we're seeing in front of us, but then they're kind of left in the dark about what all that means for their brothers or their children or their nieces and nephews. And this is really important, and it can be easily overlooked in the fast pace of ALS clinics. It's also important to prepare individuals psychologically for this information, talk about different possible insurance and financial impacts, and also the range of test outcomes. And it's important to know that we don't always get a yes or a no answer with genetic testing. Sometimes we get an uncertain result, which is really frustrating. But it's important to know about in advance. So our paper was published in 2023 in the Annals of Clinical and Translational Neurology, and you can refer your local neurologist to this paper if they don't know what testing should be offered, but the recommendations are actually quite simple. All persons with ALS should be offered single-step comprehensive genetic testing, including that C9 expansion. And we want to be sure that we're using good, solid methodology for C9 and other genes. And all persons should be provided with education and personalized risk assessment before and after testing. So with that under our belts, we then proceeded to investigate, well, now that, a couple of years have gone by, now that we've had the approval of Qalsody, how has genetic testing practice been impacted? And as of 2025, as this is brand new data that hasn't been published yet, we've found that about 30% of patients with ALS in a nationwide sample have had genetic counseling, but about almost 80% have had genetic testing. So the distinction here is, genetic counseling meaning sitting down with a board certified genetic counselor to review those personalized risk assessments that I mentioned. Sometimes neurologists do this and sometimes not, but it looks like we've really been impactful in terms of the fact that in a nationwide sample, and we surveyed the CGC ALS registry, almost 80% of patients with ALS have had genetic testing. And surprisingly, we did not see any significant difference between people who were located in an urban or suburban area and a rural area. And that was a real disparity that we had seen in the past, that people in rural areas had less access to genetic testing technologies. But that seems to have resolved, which is great news. So just to kind of step back and look at the arc of progress with genetic testing and counseling in the last 10 years. The first study I did was in 2015, and we found that only 23% of a nationwide sample of persons with ALS had had genetic testing. Then in 2019, the first free testing program began, and that was sponsored by the NEALS Consortium. So persons with ALS who were seen in NEALS clinics were able to get free genetic testing with this program. Then we had sponsored testing programs a few years after that, sponsored by Ionis and Biogen. And these programs are still up and running today. You can still get free testing through these programs. And of course, in April of 23, we had the FDA approval of the SOD1 treatment. Our guidelines were published in September of that year, and that leads us to today, where we have a 79% participation rate in genetic testing. So that's a real it's really great to see how impactful these activities have been in terms of ALS practice across the country. So moving on, it's one thing that we hit that, 80% or 90% testing rate. We also are curious to know, do people with ALS understand their test results? And what do they remember about their test results? And what do they take home and potentially share with family members? So some graduate students of mine conducted a study in 2023 to assess recall and comprehension of genetic testing results in persons with ALS. And we compared the reported result to the actual test report from the genetic testing library. And we designed key questions to ascertain comprehensions of implications of results in those with positive results, negative results, and uncertain results. And we were happy to see that most participants, almost 95%, accurately recalled whether they received a positive result, a negative result, or an uncertain result. And those who saw a genetic counselor were much more likely to demonstrate high comprehension of key implications of results. And I'll share a little bit more data about that. So among those who had positive results, the majority agreed with the question, does your result explain why you developed ALS? Then we tried to get at what is their understanding that close relatives would also have the same variant. And again, the majority got that question right. And we had different answers. We accepted different ways, whether that's 50% or moderate risk. And then we calculated a comprehension score by merging those key questions. So among those with positive results, 54% had high comprehension, 32% had mixed comprehension, and only 14% had low comprehension. So overall, this was pretty good. This was actually a little bit better than we expected in terms of what patients are taking home about their results. However, among those with negative results, the comprehension was a little bit lower. And the biggest misconception was that a negative result rules out a genetic cause for ALS. And unfortunately, that's not true. But many patients seem to have that misconception. The questions about what's the chance your relative would develop ALS, most did get that right as being a low chance for those who don't have a family history. But overall, about 60% had low comprehension. So I think the likely reason behind this is those patients with positive results are really getting a lot of time, a lot of discussion, whereas those with negative results might be getting minimal discussion. Maybe their neurologist really just says the report is negative, don't worry about it, and doesn't really take the time to go into much detail. So that's something that we can potentially improve upon with in our practice. So another kind of limitation or unknown about genetic testing is this question of penetrance that I mentioned in the beginning of the talk. So this is really important for family members of persons with genetic ALS. And people tend to assume that if you have a genetic variant for ALS, that means there's a 100% chance that you'll get ALS at some point in your lifetime. And I'm not sure if people are thinking about Huntington's disease, where the chance is really higher, but emerging data from C9 in particular, as well as other as well as pathogenic variants in other genes, suggests a far lower disease risk than was initially reported. And this is really important for people who are thinking about having predictive testing, because that testing can tell us if a family member has inherited, say, that C9 gene. But we can't tell them what they really want to know, which is, if you have that C9 gene, what then is your chance to get ALS or FTD? So the initial papers that came out about this stated that there was a 90% risk to get ALS for C9 carriers if they lived to be age 80. But in practice, that was not what we were seeing. And last year, a paper came out from a Danish group where they looked at siblings of persons with ALS who had the C9 expansion. And we know genetically their risk to have the expansion is 50%. And they did what's called a kin cohort analysis. So a very specialized statistical approach that tells us that the risk for ALS is actually much lower in people who have that C9 expansion. Overall, they estimated a 24% risk, but there was significant interfamily variability. So some families had a higher risk, as high as 60% if you had that expansion, and others were lower, as low as 6%. So this is really big news for relatives of persons with the C9 expansion, and I'm trying to spread the word. One limitation of this study is that it did not assess the risk for frontotemporal dementia in their primary analysis. And they got that feedback, and I think they're going to go back and look at their cohort and try and determine that FTD risk from these same families. Now, in SOD1, which is our second most common gene in the United States, we also see that different specific genetic variants in SOD1 are associated with widely different risks of disease. And this paper from Benatar and Anderson just came out earlier this year in Lancet Neurology, and they compiled the SOD1 variants that they believe have complete penetrance, as well as ones that have greatly reduced penetrance. So this is, if you have a SOD1 variant, it's really important to sit down with your neurologist or your genetic counselor with this paper and any other data to determine, what is the risk, what do we know about the risk, the actual disease risk for my relatives, because that's different than the genetic risk. And that is a concept that really even, many, neurologists don't necessarily intuitively understand. So again, I'm trying to spread the word, and it really has important implications for those people who are relatives and thinking about what this all means for them. So in summary, to summarize, where we're at as of 2025 with respect to ALS genetics, we're celebrating the FDA approval of our first gene-targeted therapy for ALS, and that's the Qalsody ASO for carriers of the SOD1 gene. And we now know that we have, helped make genetic testing and counseling standard of care for persons with ALS and their families. And with genetic testing, as I mentioned, we can find a genetic cause in up to 75% of familial cases and about 10% of cases with no family history. And we're also happy that most persons with ALS in the United States now have access to genetic testing, though genetic counseling is still underutilized. Though we definitely saw higher comprehension scores in our study among those patients who saw a genetic counselor. So we know that genetic counseling is beneficial in terms of those take-home messages, those implications for family members. And we're still working to understand the specific disease risks conferred by ALS variants. So as I mentioned, we've made all this progress in identifying ALS genes, but what does it mean if you have one of those genes? And that's what we're still grappling with in terms of disease risks. And of course, we're still not finding a cause for the majority of ALS, and we don't know if there's genetic causes that we don't know about yet, or if there's other etiologies that are yet to be discovered. But with that, I look forward to your questions, and I think I went through that pretty quickly, so we should have lots of time for questions.
Thank you so much, Jennifer. Yeah, we covered a lot of ground in that, so really appreciate the thorough descriptions. We do have some questions from the audience, so I'm going to kick off, and I'm going to go back and forth here with our teammate Alex here. So the first question is from the audience and says, my dad would like to get genetic tested for ALS as he may be a carrier, as 2 of his kids have ALS. We do not have a genetic counselor here. How can we get to one?
So that's a great question. Genetic counselors there's a professional society or a professional organization of genetic counselors that is the National Society of Genetic Counselors, and they have a website at nsgc.org. You can go on that website, enter your zip code, and identify genetic counselors in your area. Now, in a specialized situation like this, it would be ideal to see a genetic counselor who is, working in neurogenetics. But with telemedicine, you might be able to see a genetic counselor in a neighboring city if there's not a neurogenetic counselor available in your town. In general, family members can have testing if there's been a genetic abnormality identified in a person with ALS or in someone else in the family. So when there's not a genetic change found, it doesn't really make sense to test family members as of this time. And I don't know enough about your specific situation to be more specific, but do know that there are limitations if we have not identified a harmful genetic variant, because then there's the results of any testing down the line become hard to interpret.
Thank you.
Our next question is, how much overlap is there between ALS genetics and other neuromuscular and neurodegenerative diseases? I was initially misdiagnosed with SMA and got a genetic test for that. It's not part of any ALS panel. I got an asterisk on the test. While I've been told it's not pathogenic, no one has been able to explain that exon to date.
I'm a little bit confused. Could you repeat the question?
Yeah. How much overlap is there between ALS genetics and other neuromuscular and neurodegenerative diseases? I was initially misdiagnosed with SMA and got a genetic test for that. It's not part of any ALS panel. I got an asterisk on that test. While I have been told it's not pathogenic, no one has been able to explain that exon to date.
Okay, so it sounds like maybe this person was misdiagnosed with SMA and later ALS, and they're both motor neuron diseases, but ALS is upper and lower, and SMA is lower. So it can happen, but usually a neurologist can distinguish those two possibilities. ALS genes are usually separate from neuromuscular genes, just because we are usually able to distinguish, for example, a muscular dystrophy from ALS. That being said, there are times when someone with SMA might be diagnosed with ALS and vice versa. And you can make the argument that, yes, we should include broader panels. And sometimes people recommend, whole exome where we're trying to test all the genes. And there are also, for example, rare SOD1 variants that might look like CMT, which is a hereditary neuropathy. So very slow moving, very, not involving the respiratory system, for example. So there are rare cases where ALS might mimic another condition. And we all have to be, cautious about that and kind of keep that in our minds when we're doing genetic evaluations. Now, as far as your genetic test result, it sounds like you got one of those variants of uncertain significance. When you said asterisk, I'm assuming that means variant of uncertain significance. And what that means is there was a genetic change found, but we don't know if that variant is causing the disease or not. And that's a really frustrating situation. But we do get more information about variants with time, and some ultimately get reclassified. If you have affected relatives in your family, it can be helpful to test them. But on the whole, many variants are not harmful. So I realize it's a really frustrating situation, but it simply reflects that our technology is outpacing our knowledge. And these variants of uncertain significance are a plague that we have to deal with across all of medical genetics. And you're not alone in your frustration. But try to talk to a genetic counselor and try to keep up if there's any new information that comes out about your variant.
Thank you, Jennifer. Jennifer, I'm going to ask that you stop sharing screen so that we can go full screen with the
Oh, sure. Yes.
speaker, and everyone can see you right in center, and we'll continue with the Q&A. So, all right. So I'll take the next question. I have SOD1 ALS, but don't know anyone on either side of my family with ALS. Can you explain how SOD1 is dominant, and yet penetrance is really what determines whether one gets ALS or not? Is there a way to determine the penetrance of a genetic mutation?
That's a great question. So in this situation, with parents being healthy, we don't actually know if one parent actually also had that SOD1 variant or not. So there's two possibilities. One is that one parent also had the SOD1 variant. That is the most common scenario, and that parent was lucky enough never to get ALS. So that's the more common scenario with the SOD1 variants. The second possibility is that change is actually new in you and your parents did not have it. So that's what we call a de novo mutation. The only way to distinguish those two possibilities is with genetic testing on both of your parents. So that's not always possible, but if it is possible, that can tell us if the variant was transmitted by a healthy parent or not. And then assuming your parents are older, that would be an example, older and healthy, that would be an example of incomplete penetrance. And for many variants, we don't have much data about penetrance. So we just have to be cautious, weigh what information we know about the individual family. Testing family members can be really helpful. And also just know that many variants are not completely penetrant. And just because you don't have a family history of ALS doesn't mean that other people in the family don't also have that variant. So another way of saying that is if you have a genetic variant, it's quite possible that other people in the family have it as well, and they've been lucky enough never to get ALS. But testing of family members is really the only way we have right now to sort it out.
Thank you.
Our next question is, does whole genome sequencing have any benefits of better diagnosis or personalized treatment?
That's another great question. And whole genome sequencing, just so everyone knows, is a test where we try to sequence all the genes in the body, the coding genes that make proteins and the other genes that control gene expression, which are non-coding genes. This is very expensive. It's a ton of data to go through. And exome sequencing is another variant of this where we just look at those coding genes. So exome and genome sequencing have been fruitful in pediatric genetics, and particularly in pediatric neurology, because there's such a high burden of genetic problems in pediatric diseases. So it is for sure recommended in pediatrics. It has been less fruitful and successful in adults, and that includes in adult neurology clinics. And we actually don't have data for the clinical use of whole genome or whole exome in patients who've had negative panel testing. So I assume that's the situation that you're in, where we've done the standard 22 or 32 gene panel and we haven't found a cause. What is the utility of further testing where we try to look at all the genes? And the bottom line is we don't know. It's probably low, but not zero. It's expensive, and if you have a way of paying for it, or if you have the opportunity to join a research project where those tests are done, hopefully with disclosure of results to families, then that would be kind of a compromise approach that might be more feasible.
Thank you. I'll take the next question. I've been tested and have the SOD1 mutation. I have no family members that I know of that have had ALS. What does this mean for my son and granddaughter? What would be a good next step?
Okay, so the person has a SOD1 variant, and remember that there's more than one SOD1 variant. So SOD1 is the gene, but there's many different variants that can happen within the gene. And maybe I didn't make that clear enough in my talk, but it's easy to confuse the SOD1 with the variant itself when in fact they're two different things. Like SOD1 is, think of it as like kind of the parking lot, and then like the variant is the specific parking space. And that's, that's one way of thinking about it. But anyways, so if you have a SOD1 variant that is pathogenic or causing or increasing the risk for ALS, then there's a 50% chance for each child to inherit that. There would then be a 25% chance for each grandchild to inherit that. However, that's not the same thing as saying that the children have a 50% risk to get ALS because of incomplete penetrance. And if that variant was inherited from a parent, then that's just an example of, well, yes, not every person who has this variant will get ALS. So I realize it's complicated. The genetics are quite simple. It's a 50-50 chance with each child. And if the child doesn't inherit that variant, it cannot be passed on to the grandchild. So that part of it is pretty straightforward. What's less straightforward is the actual disease risk. And that is something that you might need input, and information from the literature, which can be limited, just to prepare you.
Thank you.
Thank you. You mentioned that some labs may run irrelevant genetic testing. Are there certain testing labs that are certified or recognized as reliable to do ALS genetic testing?
Yes, so any lab that is CLIA certified to do clinical genetic testing would be a good choice. And we have quite a few testing labs in this country that I don't know if I'm allowed to name any, but I would be happy to if that's allowed. However, be aware that there's a lot of genetics quackery, and there's companies out there who are running all kinds of non-clinical grade testing and calling it complete sequencing. And this is really dangerous because people think they're getting useful information and they're not. And I just caution you not to do like the direct to consumer testing is a red flag. So any company that your doctor's not ordering, you're just kind of sending in your sample on your own, that is a red flag. But if you're working with a CLIA certified genetic testing laboratory, and there are many, including the ones who offer the sponsored testing programs that I mentioned, that would be Invitae and Prevention Genetics, both offer free testing panels. Those are great labs that offer clinical grade quality testing.
Thank you.
Thank you.
I'll do the next question. According to the guidelines, all persons diagnosed with ALS should be provided genetic testing. However, should all relatives or family members of an ALS patient also undergo ALS genetic testing?
That's another great question. And first of all, I want to clarify the guidelines. Really, what we intended to say, and maybe I didn't make this clear, is everyone should be offered genetic testing. So we want that decision making to be individual, and it's up to the person with ALS if they want to accept that testing. But we want everyone to have access to it. Now, our guidelines did not delve into the downstream testing for family members, and that is a very personal decision right now because we don't have a treatment right now. We may one day have an FDA-approved treatment that we can give people before the onset of symptoms, but for now it's a personal decision that has implications for family planning, for career planning, for potentially insurance and long-term disability planning. So there's a lot of those considerations which are highly individual, and because of that, it's harder to make a firm recommendation that this is something that should be done. I believe that it should be offered, but first we need to give those individuals correct information about what are the limitations of testing. And like I said, we can say if they've inherited the variant, but what is the risk of disease? And that sometimes is a much harder question to answer. So there's a lot of complexities to it, and that's why it's kind of a separate discussion that really should be had on an individual basis with a genetic counselor.
Does this have any effect on access in terms of testing for, for family members when it comes to, say, accessing the tofersen trial? Or is that more, is the genetic test alone what's needed, or is being symptomatic also required for trials?
Is the question about the treatment or the
There's a follow-up question about, because in theory, this would define the patients in the genetic treatment, at least in the tofersen trial, for instance.
Right. So we have one trial that is for people who are people who are not symptomatic but have a SOD1 variant. And you do have to have that variant in order to enroll in the trial. And what they're doing is they're following those people with biomarkers, and once the biomarker of neurodegeneration pops up, it's called neurofilament, then the treatment is given. So it's not just anybody. You have to, number one, have that genetic change. You have to have an increase in your neurofilament. That could change in the future. But generally speaking, you have to have genetically proven SOD1 related ALS to get the FDA approved treatment. However, the way the label is written, it leaves it open about like what kind of variant it is. So it's kind of ambiguous about, can it be a pathogenic variant or a variant of uncertain significance? And that is kind of a debate that's going on in the field right now, is to like, what is our threshold going to be for what we're defining as a mutation? Because the label actually says mutation, and that's not a term that we actually use in genetics anymore. So there's some ambiguity there.
Thank you. Our next question is, I had genetic testing 8 years ago and we mapped the gene throughout our family tree. However, there has been no research progress in finding a way to repair the gene C9. Have there been any advancements in therapies targeting C9?
Yeah, that's a great question. And I alluded to the fact that we've had some setbacks with C9 in particular, with products that were kind of in the early stages and were not effective in clinical outcomes. And in fact, clinical outcomes may have been negatively impacted. So right now, I'm not aware of any imminent clinical trials for C9 in this country. And I feel badly about that, because C9 is such an important gene for our population here in the United States. But know that many researchers are working on it. One of the challenges is, what is the disease mechanism? And C9 actually has that expansion impacts the cell in more than one way. And we're not sure, is it one particular way that's the leading harm, or is it the combination of all these different things? But there's a lot that gets impacted and affected in terms of the cell and the cell's gene expression in the C9 gene. So please, keep asking and keep checking clinicaltrials.gov, keep asking your clinic, because that could change any day. But for now, I'm not aware of any imminent clinical trial in the United States.
Thank you.
Could you say for how VA-connected ALS patients are offered genetic testing?
How are VA-connected patients offered testing? Mm-hmm. Yeah, so that's a good question as well. And it seems as though there's some data that indicates that patients who are seen in VA clinics are somewhat less likely to have genetic testing, but it's not a zero number, and I'm not quite sure why that is. I know that some veterans are afraid to get genetic testing because they think if a genetic cause is identified, they'll lose their service-related benefit. But I do know that the FDA specifically has guidance that a genetic diagnosis will not impact your eligibility for ALS as a service-related condition. So even though people are worried about that, the FDA has and this is in writing, that you're not going to lose your benefits if you do happen to test positive for a genetic form of ALS. And as for getting the testing, like I said, it is free. If you can find a neurologist or a genetic counselor who's able to order it for you, it doesn't have to be at the VA. You could go outside the VA system, theoretically.
Thank you.
For those of us who have sporadic, what can be said about the transcriptome? showing which genes are expressed into RNA, and the epigenome, the set of chromosomal modifications that establish which DNA regions are accessible.
Yeah, so this just refers to which genes are turned on, and are those genes different in someone with ALS? So that's a really complex question because we have thousands and thousands of genes, and each of those genes might have different, transcripts or isoforms that they make. So this is a complex question that there's been some investigation in this, I believe, in cell lines, for example. But as of now, we don't have any answers as to what is the cause of sporadic ALS. There's a few risk factors that we've identified, but we don't know if there's anything useful in terms of genetic testing that can be gleaned at this time. So I personally wouldn't, seek anything through, like, for example, the direct-to-consumer testing. I would, participate in research if that's an option. Many research projects involve or include genetic testing as part of it. So that is a way to kind of participate and contribute. Despite not having a genetic diagnosis, you can participate in research or research that includes a genetic component.
Thank you. Here's a case in which there are 5 family members who have ALS. Within that family, 3 of us had genetic testing, but all came back negative. This test was done by swab in the mouth. Is there a blood test that is more accurate?
As long as it's one of the, CLIA's certified labs that I mentioned that is certified to do clinical testing, it should be fine. When the buccal swab fails, it doesn't get enough DNA to run the test. So it's not like it gives bad DNA, it's just not enough. So that does happen sometimes, and blood is the standard, and we get the most high quality DNA. So if you're concerned about it, you could repeat the test on blood, but I wouldn't expect to find anything different, assuming that you did work with one of those certified labs. This is one of those 25%. Remember, I said we find a genetic cause in about 75% of familial cases. There's still 25% where we don't. And in those cases, and that I would say your family falls into this, we suspect that there is a genetic cause that we don't know how to test for yet. And again, your family would be a great family to participate in research, and the more family members that join, the greater the likelihood is that we could use your family to find that gene. So for now, I know it's frustrating to be told, well, you have familial ALS, but we don't know the gene. But that is unfortunately where we're at. And just be aware as new genes are discovered. You can ask your doctor, hey, was I tested for this new gene? I will say that the pace of gene discovery has slowed down quite a bit, but it's not zero. So if new genes are discovered, try to be sure that you get an updated test.
Thank you.
Thank you. This person says, I'm curious to hear more about the G93A penetrance, as most preclinical studies are done in G93A mice.
Yeah, so I would have to go back and look at the papers. I don't know the data off the top of my head, but if this person, or if you could take down this person's email, I could get back to you more specifically, because I would hate to tell you the wrong thing. And there's so many different variants that I can't keep the penetrance data all in my head, but I'd be happy to see what's known and get back to you by email.
Yep. Thank you.
Thank you. Why doesn't TRDBP get as much attention as SOD1, C9, and FUS relative to trials, etc.?
That's a good question. I think I would say it's largely that it's not as common as those other 3. So in our population here in the United States, it's the 4th most common. C9 is first, second is SOD1, then we've got FUS, and then we've got TRDBP. And I really don't know beyond that. It's really hard to run a clinical trial when there's not many patients available to participate. And I know that Ionis has really struggled with this, with the FUS trial. It took them a long time to get enough patients enrolled, and the trial went on for quite a bit longer, I think, than they anticipated. So it's just really hard when there's not very many patients to get the logistics, all of the expense, all of the training and recruiting, and all of the work that goes into a clinical trial, unfortunately.
you.
Thank you. How much more information and a possible gene detection can one get from a whole genome sequencing if an initial genetic panel test was negative?
Yeah, so this question I already addressed, we don't actually know. I haven't seen a study of using clinical grade whole genome or whole exome testing in persons with ALS who've had negative panel testing. As I mentioned, in pediatric conditions, we always recommend that, whole genome or whole exome. But I'm not sure there's enough evidence to make that same recommendation in persons with ALS. It certainly can't hurt, but it's an expensive test and the yield is probably low. It's not zero, but it's probably low. And even if we found a gene, it's going to be a new gene maybe that no one's ever known about. So it's unlikely that there would be a clinical trial and that it would be actionable in that way. But, of course, discovery is important. And I know that if I came from a family with ALS and we didn't find a cause with panel testing, I would for sure want exome or genome sequencing, just with the realistic expectation that it's expensive and we might not get any useful information.
Thank you.
Thanks. What is the penetrance of the TBK1 gene defect?
So penetrance really is variant dependent. And I know that I keep talking about C9 penetrant, but remember that everyone with C9 has the same variant. It's that C9 expansion. So in that way, it's a little bit easier to talk about penetrance in C9 because everyone has the same genetic change, that expansion. So TBK1 in general, I believe the variants may have incomplete penetrance or reduced penetrance, but we really need to look at what's known about the variant itself, and also the family history can inform estimations or discussions on penetrance. And I would say that reduced penetrance is more the rule than the exception. And it used to be the other way around. People used to think that SOD1 genes are completely penetrant, C9 is completely penetrant, and the people who live to be 90 without disease are the exceptions. But I think we're learning that that is not correct in general.
Thank you.
Our next question is, what are the compensation in terms of encouragement given by the ASO's developing company to patient for genetic counseling? Any advocacy initiative going on there?
Can you repeat the first part of the question?
Yeah, what are the compensation in terms of encouragement given by the ASO's developing company to patient for genetic counseling?
So, so pharmaceutical companies, including Biogen and Ionis, pay for genetic testing at these clinical grade labs that I mentioned. So that's one way that they're essentially providing a service to the patient. Now, of course, they have their own ulterior motive in that they're trying to identify customers for their product. But the clinical service is a good one. And in addition to the free genetic testing, there is also the option to have free genetic counseling that is also paid for by the program. And there's a specific box that you can check on the test order. So the ordering neurologist or the ordering genetic counselor can check the box to say, please contact the patient for genetic counseling about this result. So that is available, and I'm not sure if that's what this person is asking, but there's no payment, but there is a free service that's provided as part of these programs, and that includes both genetic testing and genetic counseling.
You may have answered this already. Thank you, by the way. You may have answered this already as far as access to a trial within the U.S., but there was a question about when you expect a C9 or 72 trial, and I guess we'll specifically.
Yeah, as far as I know, that's on hold. I don't have any insider information on that. I'm sorry. Maybe when Dr. Kolb comes in a couple of months, you can pick his brain about that because he might know better than me. I know there's been setbacks, and it was a disappointment to all of us who've been, waiting. But I know there's a lot of people that are working on it, and C9 has some challenges that I mentioned.
Thank you.
Regarding TARDBP, what is the most up-to-date penetrance rate and or when will we have this information?
So again, TARDBP is the gene, and we need to think about penetrance on a variant level, usually. So it really depends on the specific variant, but in general, this is a gene that can have incomplete penetrance. So again, we need to consider the specific variant. We need to consider the family history and what we know about anyone else in the family who's had ALS or not. But in general, this is a gene that can display incomplete penetrance, meaning that even if you have a variant, a harmful variant in that gene, doesn't guarantee that you'll get ALS.
So here's a question about our IVF. Do you have resources or recommendations on nonprofit organizations, grants, et cetera, that may offer financial support for positive gene carriers interested in seeking IVF? Where and is cost a factor? Is this something that genetic counselors are able to support?
Yes, so it is very expensive, and to be clear, IVF itself is very expensive, but to do the pre-implantation genetic testing is another layer on top of that. So, typically embryos these days are tested for their chromosomes. So that's one, already significant cost. And then to do an ALS gene on top of that would be another, expense. And I didn't mention it, but usually you need a parent, mom and dad, in some cases a grandparent, to set the phase. And it's a technical process, but they don't test for the genetic abnormality directly. They look indirectly. So sometimes you need multiple family members to participate in this. And it can be, in the tens of thousands of dollars. So, it, depending on your location, it's going to be at least probably 20 or 30,000. Now, I've heard that for Huntington's disease, they do have a grant program that enables families to apply to get funding to cover at least part of that kind of specialized IVF. I'm not aware of anything like that for ALS at this time. Nonetheless, I would still recommend talking to a genetic counselor or talking to specifically a prenatal genetic counselor to find out what the costs are, and if need be, plan for it. There's also traditional prenatal diagnosis, I should say. So things like amniocentesis or CVS, those procedures can also be used to identify the genetic variant early in pregnancy.
Thank you so much. Any final thoughts on what the first step in that process is in terms of reaching out to a fertility clinic or elsewhere?
Yes, so you can ask your OB for a referral to a fertility clinic and just explain, the situation. You would need confirmation of the genetic diagnosis or the gene that is in the family to begin talking about who would be needed in terms of family members for testing and what the cost estimates of all those steps would be.
Thank you. The next question, I'll jump in. I'm in the PMP program and had genetic testing, but my results are all negative. Is that normal? Also, do you know what kind of genetic testing they use?
PMP program, I'm not familiar with that.
I am not sure also, so we might get some follow-up from the audience from that, and we'll keep going.
Okay.
Yep, go ahead, Alex.
I can hop in, sorry. In your opinion, are genetic mutations the major cause versus toxins or head injuries, sports, military, etc.?
Harmful genetic changes are definitely a established cause for a minority of ALS cases. As to what's the cause for the other cases, particularly those that don't have a family history, I think we have far less data. And we have some evidence that head injury, some evidence that specific occupations or sports exposures or lifestyle exposures, there's some increased risk there, but it's not to the degree that we see in a single pathogenic variant, for example, the C9 gene or the gene variants that we've been talking about. So how you define cause, your question gets to how you define cause, but I would say that it's these genetic forms of ALS are really unique in that we can say, this clearly is the cause, if not the, main cause, even though the risk is not 100% to get disease necessarily when you have one of those variants.
Thank you.
Circling back, on the PMP program, that's the precision medicine program being run by ALS TDI.
Okay, so I'm not familiar with the specifics of this, but I assume they've at least done a multi-gene panel, and potentially beyond that to maybe include sequencing, genome exome sequencing. So, you really should ask, the person who offered you that test, what are the limitations of this testing? Is there anything further that you can offer in terms of trying to provide me with additional genetic risk assessment? And, like I said, if the sequencing or the genome or exome hasn't been done, that's something you can consider, but the yield might be low. And it's frustrating, not to have an answer, especially when there's more than one person in the family who's had ALS. It's really frustrating.
Thank you. I think we've got to the end of our questions, unless we've got a couple more in the audience. There was one, Tracy. I think I saw you going back and forth with Lyle, and it got pretty involved. So I think I'm going to skip it for now because it looked like it was pretty specific. But what we can do is connect you directly afterwards if you'd like to, Jennifer, if that's okay with you.
Yes, of course. Yeah.
I got one last question here, and it looks like it's a little bit involved, but how can we make sure neurologists and ALS clinics understand how different genetic variants can present with different diseases and family histories, and take that into account when diagnosing and managing ALS? How can we fix this gap in education and misunderstanding that ALS doesn't cause cognitive changes? The example she provides is that her father's first clinic skipped testing since he was first in his family ever diagnosed, and saying familial ALS was only 10%, so not worth testing, even though we shared that his grandmother had Parkinson's, which later turned out to be a TAR-DBP variant. His second clinic finally tested, but later dismissed FTD as the cause of his cognitive, behavioral, and emotional changes, despite the confirmed gene. Once he had a neuropsych exam by his neurologist specializing in FTD, he was diagnosed.
Yeah, I'm sorry that you went through that long journey, and unfortunately, it's not uncommon. Because these genes overall are still rare, and historically, it's true, we only offered genetic testing to those with a strong family history of ALS. So our practice has changed, and I guess I wouldn't necessarily say that the team did wrong. Now we know to offer complete genetic testing to everybody as soon as possible. But we didn't necessarily practice that way in the past. But we're learning, and our families are teaching us. Families like yours are helping us learn. And it's really important to be humble and accept that we don't know everything. And let's keep our eyes open. Let's listen to patients and families, and let's think about the possibilities. So that's something that I always try to do. I try to remind my team and the families that I see that we are all learning together. You can help a neurologist learn by sharing your stories patiently and persistently. You can gather information on your family history. You can also gather medical literature. That is something that neurologists are trained to pay attention to. And if you can present a paper about that particular gene, if you can present that guidelines paper that says you should be offering testing to everybody in a friendly way, then you usually can get people to pay attention. And we will learn, we will improve, we will get better. So thank you for your patience in helping us do that.
Jennifer, thank you so much. We've gone through all the questions here. Really appreciate the time you've taken to walk us through.
I have a question.
Oh, go ahead, Don.
I'm an anomaly. As far as I've found, I'm one of the longest surviving people on the earth for some reason with ALS. My symptoms started 46 years ago when I was 19 with slowness in my writing, and then it wasn't enough to even go to the doctor to say, hey, I can't write fast, and it progressed in my 20s, went to foot drop, and became pretty obvious by the time I was 32 and found my way to a neurology after many misdiagnoses. Anyhow, genetically, I was finally tested when I was in the CREATE study. I'm thinking that was like 5 or 6 years ago, and it took a year to get my full genome analysis, and I felt like they were telling me, "Oh yeah, we'll have a gene, what do you call it, a gene counselor talk to you, a genetic counselor," and we're excited that they might find something, but it finally just came back nothing. I tested negative for any of the known variants, and then I got involved with Synapticure, and a couple of years ago, and they told me there was some new variants and new mutations, and so I did again the swab testing through, with one of the companies you mentioned. Anyhow, and it again came back negative for any of the known variants. So I'm now in the all ALS study. Both they have a study where I'm going in for MRI every 3 months and taking blood and doing other neurological tests. And I'm also in the home visit one. I've just got it started with that, but I'm wondering what else can I do because I really think my case might be lead a lot of clues if they can figure out what's behind this, because all my neurologists say, yeah, you've got ALS, but you don't have the prognosis of ALS. In other words, I basically, if you look at my scores and everything else, ALS, FRS, it stopped progressing about 10 years ago. And so they're interested in finding out, and I'm wondering what your thoughts are. The only thing I asked my the head neurologist and very active in the research community. His name is Dr. John Ravitz, and he took a skin sample and is basically cloning my cells as well. And I've told him that I think he should do some kind of presentation at the International ALS Symposium, which is being held in December in San Diego, which is where I live, and to just let all the researchers know that I exist, and he's got the samples and all my data if they're interested in it. Anyhow,
Don, thank you for sharing your story, and it's pretty extraordinary, and it's got to be incredibly frustrating all these years trying to get to an answer. And
well, I want to find out for myself, and I also think I want to see my, and not just written off as an anomaly, but if I really do have ALS and it just stopped progressing, I want to find out what gene I have protective or what it is, what's going on. Any thoughts on this case, Jennifer? Have you heard of anybody else that has
So
lived this long?
any research project that you can join that involves, genetic testing and screening, I would try and do that, even though you'd already participated in Create. And I'm sorry, I've lost my camera. I'm sitting at a desk that I don't usually have Zoom meetings so late, so my lamp is not working. So I apologize, but I am here. And the other thing that I didn't mention yet that you might think about is DNA banking. And unfortunately, the lab that I like to recommend for this, Prevention Genetics, no longer offers this service. But basically, DNA banking is when you contribute a DNA sample to, typically it's a commercial lab, and they store your DNA indefinitely. And what this enables is if a gene is discovered later on, or multiple genes, your DNA can be tested after you're gone, and then family members can potentially be empowered by learning, having the benefit of that additional, more advanced genetic testing. So you can ask locally if there's a DNA banking that is available with the team that you work with. Unfortunately, Prevention, which was my go-to, stopped offering this service last year. So that's a real disappointment, but just know that it is a possibility, and someone like you would be a great candidate for that.
Thank you, Jennifer. McFinn, we're going to turn it back over to you. Jennifer, thank you so much for the time you've given us and for all the answers and the guidance you've provided. It is a fast-moving, I know oftentimes confusing space in genetics, and genetic counselors do their best to always keep up and keep on top of the constantly evolving landscape and all the new tests. So we really appreciate your presence and your willingness to walk through this. And it sure seems like there's a lot of education to do that's even at the most basic levels, so people understand the difference between, penetrance and variance versus just individual genes that we're talking about. So I'm sure we'll have more work to do with you.
Thank you so much for having me on. I really enjoyed it.
Thank you so much, Jennifer. We really appreciate it and hope that you're taking really good care of yourself so that you can come back and inform us more about our journey.
Thank you. McFinn, we're going to give it back to you now and to our community.
All right, folks. We heard a lot. Once again, as I always say, it came right to your living room. How easy could that be? I have a question. Have any of you had genetic testing, and what was your experience with it? Was it easy? Did your doctors offer it to you?
Tony here. McFinn, I had genetic testing. It was taken through the blood, and to be quite honest, based off a lot of these conversations, I have more questions, but they weren't able to tell me what gene it was. So I think I'm in the 90%. So.
Thank you. Thank you, Tony.
Bonnie? Susan had the testing, and it was very easy to do. You just send a swab in. It was done through the mail, and then we got some called back when somebody discussed the results.
Thank you, Ruben. Folks, it's each one of us is super important, and any experiences that we've had that we can share just makes everyone else feel a little bit more comfortable following in your footsteps. Bonnie, hi, good to see you.
Hi, nice to see you. Yeah, my husband Sam was tested right after we got his ALS FTD diagnosis. And so we had worked through his neurologist. He ordered it. His FTD doctor ordered it, and it was through Invitae. And it was very easy. They sent the kit here to the house, and it was an oral swab. And then we just sent it back. But then it was followed up by a genetic researcher to talk and ask questions and so on.
Thank you, Bonnie. Very important, your experience and everybody else's experience and sharing it with us. Monica, can you come aboard, please?
Yes. Hi, McFinn. Hello, everybody. The day I was diagnosed with ALS, my neurologist went ahead and did a blood test, and it turned out that I didn't have any kind of gene. So that's really all they told me about it, and I didn't know whether to ask more into it, but now I'm just wondering what the real deal is.
Anyone care to comment on that?
I'm one similar to Monica. I had the test done and it came back negative. But my doctor sat with me and reviewed the test, and it made me feel better that there were no genetic causes, but still mystified. I have ALS.
Thank you, Tom.
That's all.
All right. Thank you for your experience. Very important. Maggie, come aboard. Take yourself off mute there. There, you got it.
Hi,
Hi.
I'm Maggie. Thank you for answering all my questions. I was tested through research actually 1 year ago tomorrow. So I tested just using they mailed a kit to my house, and it was just like a saliva swab, and then I mailed it back. But before that, I received genetic counseling a few times, and then during and then after, I participated in a couple different studies for genetic ALS, like long studies that I go in person, and so I receive the genetic counseling each time I go. And it's been a lot to learn, but also I'm grateful that I tested so I can be empowered with the knowledge and use my story to also advocate and continue to raise awareness.
Thank you, Maggie. Very important. Thank you so much.
Maggie, and please keep in touch with us in the community here, and we'll be happy to stay in touch with you as well about what you want to do next.
Thank you. Yes, my dad just passed 5 months ago, so I haven't really been super involved, but I'd love to get in touch and see how I can help.
Okay. You found your extended family, dear. Welcome.
Thank you.
Cherry? Okay. Thank you, dear. Cherry, you want to come aboard?
Hi, McFinn. I
Hi.
just wanted to come in on the tail end of what Tony was saying. And Tony was tested. He was tested for C9 and SOD1. He was tested for C9 twice. But what we really lacked was the knowledge of any of that information. They really didn't help us. I mean, we had to kind of go back and find out, were we positive for that? Were we not? We haven't had any counseling on that. It was just kind of, oh, you're negative. So we weren't aware that there was other, subcategories within some of those that can be, defined. So yeah, we didn't get the follow-up. We did get the 2 tests, but that's it.
Thank you. Every experience, folks, is a little nugget along the trail that we're sharing with each other. So, Emily, please come aboard, dear. Take yourself off mute.
Yep, I had to do mute first. Thank you for that. I was in the same situation too with my sisters. So first we had genetic counseling before to make sure that we understood exactly like what she said, mentally, if we were stable enough, why we wanted to know. So with two other sisters and myself, only two of us went forward and got tested. And it was very, very easy. And then when we got the results, we did it together. We went in person, and both found out that we were positive together. So it's just been really interesting to have this whole path and to do this. And it was easier because we have family members that have all had it. And the other thing I wanted to say is our genetic counselor too, this had been 2+ years ago, said that no matter what, it's 100% going to happen to us. And now I think with us really digging into our family tree, we are finding gene carriers that passed it on that didn't show symptoms. So we're just digging into that and doing a whole bunch of different clinical studies and sharing our stories. So,
Thank you, Emily. Thank you.
Yep.
You know, when we all share our stories, we all feel a little bit closer. And
Yeah.
Eddie, I'm all with you. You know, folks, is there anyone else who would like to say anything? Okay, well, then we're coming to that special part of the day when we all get to say, hi, Steve. Hi, Tony. Everybody want to pick out somebody who they saw tonight and say goodnight to them? Let's do it on 3, 2, 3. Lyle, did you have anything to say? Nope.
Yeah, I was saying goodnight, but I actually, one comment I would make is that, there really is more therapy development for these genetic types of ALS than ever before. And the reason is that the industry companies think of them as de-risked, because the problem we have with most ALS clinical trials is that we know that everybody's biology is different, but we don't know which drug is going to work for which people. And so if we have a therapy that's designed against a particular mutation, then we know which people to give it to because they've got the mutation. And I saw some comments in the chat that some people mentioned Silence ALS. Silence ALS is this program by Lorem where they're kind of custom designing these gene therapies for ultra rare mutations, for ones that like, maybe 3 or 5 people have. And it's slow, and it's slower than any of us want. And it's frustrating because there's people who it's not working soon enough for. And even when they develop the drugs, we don't know that they're going to work. But it is sort of the wave of the future because they're using people's own skin and their own cells to make custom gene therapies. And the people living with ALS who are participating in that program and some of the other ones like that really are the ones who are paving the way for what's going to be the future when we have much more, customized gene therapies. I also saw some people asking specifically about C9 and TDP43. I can tell you there are dozens of companies right now developing drugs specifically for those 2 genes. They're probably the most popular genes being targeted in all of the ALS pipeline. And just realize even a few years ago, this was all science fiction. And so now with SOD1 and with FUS, we know what's possible. And I think it's just, none of us want to wait. We all want it to be ready right away, but the progress is remarkable. And the conversation would have been very different if it was even 5 years ago.
Mm. Yeah.
Thank you.
I'll just add that if you haven't signed up for any of our observational studies, this is exactly what Lyle's talking about, is that it's a combination of genetics and a combination of getting to understand people's potential initial presentation and then progression through these sensors that we offer that really help start to create better defined segments of populations within ALS and maybe help redefine the disease itself to be less syndromic defined and much more precision defined. And so we got to do this all together. We do have new studies like that specifically for gene carrier and asymptomatic study, and we are looking to launch more of these technologies towards direct trial readiness, where the more we're participating, the more we can start to match people directly into studies. So please stay in contact. Please consider joining those studies if you haven't already. And make sure we're all here. You can reach out to any of us as well if you have additional questions of how you can help, how you can be a part of the programs, how you can help explain what we're doing to friends and family who might want to be involved as well.
Thank you, Christian.
Is all that on your website, your information about the studies you're doing?
Yeah, I'm going to put it, if you can click on the link, I'll put it in the chat, but it's also, when you go to the website, it's under the research section of the website.
Okay, because I hate to see there be too much overlap. I'm already in, a couple of studies with the all ALS. So I don't know how communicative they are between the different studies.
We are very much talking to each other all the time. We are on each other's kind of calls quite often. We work very closely with James Barry and others who are part of that. He's actually an advisor to us as well. It's really up to your ability and comfort level. If you want to be able to participate in studies, or if it's just too much and you just want to focus, that's okay. Totally okay. It's up to your comfort. We're doing things a little differently in that all of our studies are completely remote. Everything is completely done via the sensors that we send you, as opposed to being in clinic as well. So each of the protocols kind of have their different flavor. Our goal is to get all new measures out there that are.
What are the sensors? What is that?
So we're not using any sensors. Sensors. Sensors, yeah, like sensors that you can wear on your ankle and wrist, or speech capture through the app for speech progression, to get really nuanced understanding of potential speech progression, far more than what's captured every few months if you're only relying on getting into clinic, hopefully, and also some cognitive assessments and other tools that are in the app. There's also just some, everyday lived experience type components of the app as well, like being able to track your diet, and the nutritional elements of your diet, for instance. So by all means, if you haven't downloaded the app yet, you can learn a lot more about the studies there and about the different resources we have. And to it, is there all these videos actually of all these programs get stored there too, and they're wrapped with generative AI, so you can continue your conversations and questions there as well for additional resources.
Sounds good. I'm hoping something positive will come out of it. I mean, my brother's told me, oh no, you shouldn't do that. MRIs are bad for you. I couldn't find anything anywhere that said that, but he's a conspiracy theory guy. So
if nothing else, you can always email us at info@EverythingALS and ask any question you've got.
Yeah.
Don, just as a quick aside, so last week I was at two ALS meetings, actually last 2 weeks in Australia. And the first one was a meeting called PACT House. And so you guys have probably heard of NEALS, which is the thing we have in this country that runs the trials and the registries and all these efforts. And NEALS is the Northeast ALS Consortium. And PACT House is the Pan-Asian Consortium for trials and research in ALS. And it's all countries, China and Japan and Malaysia and Myanmar and a bunch of very small countries, and also Australia. And many of them are very resource poor. And they're trying to do what we're doing here, meaning they're trying to set up these sorts of registries and remote data collection and ways to get genetic testing. And forget the fact that there's no resources. It's quite remarkable, just the psychosocial barriers. Like in cultures in a lot of these countries, it's embarrassing to say that your family has a disease that runs in your family. And the last thing you're going to do is go to a clinic and have everybody's blood drawn. And, there's very little understanding of what the word genetics even means in some of these places. In the country of Myanmar, they're trying to do this stuff, and there's 50 million people who live there. And in the whole country, they've only got 41 neurologists. And so, in some ways, and the purpose of the meeting was to figure out how to do things more globally. And what Christian was just talking about, a lot of the remote collection efforts, a lot of the things that Everything ALS is pioneering, and some of these other groups are hopefully going to allow people wherever they live to participate in trials and to contribute data and contribute information. It's also interesting, just from a genetic standpoint, If you live in an Asian country, you're much more likely to have SOD1. They don't have C9orf in the Asian countries. And so learning about the different genetics is different. But, we live in this global world. And when you talk about, as long as you're participating in some studies, that's awesome. Everybody truly is sharing data. The data will be shared. You don't have to worry too much about doing everything, although there's some people on this Zoom right now who I know are in like 40 studies. But everybody's sharing like never before.
Thank you, Lyle.
Mhm.
Thank you to everyone this evening. All of you made this all possible. You make us continuously possible, and we are grateful that we can serve you and that you are on the team. You're not just somebody sitting in a chair. You've got plenty of wisdom inside. Please do any homework that you would like and share it with us. And with that, thank you again for being here.